So now we move on to normal distribution, right? A normal distribution. So what is the normal distribution? Got a couple of pictures of it. Basically, in nature, when we're looking at the mean of something like height per se, there's going to be an average height, and there's going to be shorter people. So average height here is represented by 0. There'll be shorter people and there'll be taller people. But the way they're distributed is not uniform. That is to say, the amount of people with average height is a lot more than the amount of people that are really tall. Like I'm 6'3", 6'4". There's not a lot of people my height. There's a lot of people that are 5'10", 5'8", and then there's not a lot of people that are 5 foot tall, really short, right? So this distribution is representing in nature the way that a lot of things are distributed, right? So there's very few on the very high end, there's very few on the very low end, there's a ton near your average, near your mean, and it slowly slopes down after that. So, and in general, the cool thing is that this distribution can be used for a lot of different scenarios, right? When we talk about mean, and we talk about the distribution of that mean, or distribution of that variable, whatever it may be. I just like using height because it's easy to relate to. Okay, so this is the normal distribution. Okay, we're going to be working with this. It's a bell curve. Practice drawing it. It's great to draw stuff in statistics, right? I had a statistics professor, one guy, he always said, what are the first 3 rules of statistics? And we'd all have to answer, draw a picture, draw a picture, draw a picture. All right, so this, you should always be thinking of this picture in your mind, drawing it on a piece of paper when we need to think about problems that use the standard normal. Okay, so problems that use the standard normal. Let's see. Computing the z-value. Now, we don't technically need the standard normal picture for the z-values. All right, there's an easy formula. But what the z-values are doing, okay, and these values in the bottom here, those are z-values. Okay, it's telling us where we are in the standard normal distribution. All right, so a z-value of 0 means we're at the mean. Z-value of 1 means we're 1 standard deviation above the mean. Okay, z-value of 2, we're 2 standard deviations above the mean, right? And from the empirical rule, remember the empirical rule, all right? 68% of the data will be within 1 standard deviation, so from -1 to +1 of the mean. 95% is within 2 standard deviations of the mean, so between -2 and 2. All right, so these z-scores are telling us, how far are we from the mean, how many people are taller than us, how many people are shorter than us, right? You can think of it that way. So there's lots of different questions that can be asked. But right now, we're just computing the z-value. Okay. So a normal population has a mean of 12.2. What is 12.2? Maybe it's years of education, 12.2, for some population. All right. Now, since we know this is the population, right? This isn't just a sample. We know this is a population. We know the population mean, and we know the population standard deviation. Okay. We can use z-values. All right. Z means you know the population mean, you know the population standard deviation. All right. And the population mean is denoted by mu, and the population standard deviation is denoted by sigma. So excuse me. So here, z equals the value you're looking at, x, minus the mean, the population mean, mu, divided by sigma, standard deviation. Okay. So, how do we compute the z-value associated with 14.3? Well, 14.3 is our x, 2.2, the mean, is our sigma, is our mu, and 2.5 is our sigma. Sigma, it's just this little circle with a tail. Mu, it's kind of like a U with a long start there, right? So mu, U, right? You can get that. All right, so using our formula, we've got what we observe. We've got our population mean and our population standard deviation, right? So we observe is x, this is mu. Ooh, let's see if we can find a mu. There it is. And this is sigma. And I might have trouble finding sigma. I'm just going to write out the word because I don't want to have time. Alright, so x was 14.3, mu is 12.2, sigma is 2.5, right? And so z equals x, so what we observe, minus mu, divided by standard deviation, population standard deviation, 0.84. Alright, hopefully that's right. 0.84, good. Alright, so that's just finding the z-value, right? Finding the z-value. So that means whatever this population is, you're above average. You're above the average. You're within one standard deviation of the mean, though, so you're not too far above average, but you're above average. Okay, now it's asking us what proportion of the population is between 12.2 and 14.3. Now, here we need to go to our z table, our z chart, all right? And this chart is going to tell us how much of the population are you above, or how much are you above the mean by, right? How much of the population lies between you and the mean. Now let's see if we can figure this out. So this z table, okay, this z table is telling us the percentage of the population that lies below the z-score, all right? So if we go to 0, we should get 50 because half the population is below 50. So here we have, 50%, okay, 50%. And same thing if we go to positive 0, right, 50%. Okay, and this still is telling us area under the standard normal curve to the left of z, all right. So the standard normal, again, it represents the whole population, so the area below it is 1. Half of it is below 0, the z-score of 0. Then if you use the empirical rule, between -1 and 1, there should be about 68% of the population. Between -2 and 2, there should be about 95% of the population, okay? But this is just telling us how much of the population is below the z-score, all right? So the z-score we found was 8.4. So we go on to z, here we go to 0.8, and we go over to 0.1, 0.2, 0.3, 0.4 right here, right? And we see that 79.95% of the population, about 80%, is below 14.3, right? Whatever that number, 14.3 years of education, I think I said. All right, so 0.7995% is below that. You can almost think of this as a percentile, right? 14.3 is the 0.79, 0.95th percentile, right? So about the 80th percentile. Now the question was asking what proportion of the population is between 12.2 and 14.3. Now 12.2 is the mean, all right, which means that 50% is below it, right? The mean in this example, in standard normal curves, the mean is the median. The median is where you're 50%, you're above 50% of the data, right? So between 50%, so this has 50% below it. This one had 79.95% below it, right? So what we do is to find what's in between. We take the 0.7995, and we subtract the 0.5. We subtract the mean. All right, so we take the percentage of the population below where you're at, subtract the percentage of the population below the mean, and that gives us the percent of the population between where you're at and the mean. Okay? Now, if you draw a picture of this, it might help. So try drawing a picture. All right, so we got about 80% minus 50% should be about 30%. And then 0.2995, right? That's that 995 we had. So 0.2995 is the proportion of the population between 12.2 and 14.3. All right. So how about less than 10? So it's asking us now, find the z-score where we're at 10, using this mean and the standard deviation. Find the z-score at 10 and go to the z-chart and tell me what's below that z-score. I call them z-scores. You might hear z-values. Okay, so x is 10, negative 0.88. We go to our z-score, z-table, negative 0.8, and we can't really see the top there, but 8, 0, 8, 1, 2, 3, 4, 5, 6, 7, 8, right here. So 0.1894, that should be the answer. 0.1894, good. All right. So do a lot of practice problems on this. Do as many problems as you can with this stuff, all right? It should make it easier the more you do it.